Let's now make a tour over the CPI2-Go2 graphical user interface that enables control of CPI2-Gx gang device programmers that are intended to program multi-PCB panels. This programmer can be equipped with 2 to 7 programming modules, and multiple CPI2-Gx programmers can be cascaded to flash a virtually unlimited number of devices in parallel. The gang programming mode, if it's controlled from the CPI2-Go2 graphical user interface, has the following fundamental restrictions. Only the same device type can be programmed on all sites. All the sites must share data loaded in the same buffer. Only the same auto-programming batch of commands can be executed on all sites. Let me emphasize that these restrictions relate to the GUI control mode only. Use of a standalone mode, or an application control interface, or a command-line control mode enable to bypass these restrictions. So, in general, the programmer enables to create and run different projects for different programming sites and concurrently flash different types of devices with different data on the same target board. Each module in the programmer has a built-in demultiplexer that can be enabled by an optional license. The CPI2-Gx is a general abbreviation. A particular model part number refers to the number of modules installed in the programmer. For example, the CPI2-G06/12V1 part number refers to a 6-channel gang device programmer. Now onto the programmer startup. When you launch the CPI2-Go application for the first time, it prompts you with a wizard where you need to specify the programmer model, the mode of use, the gang mode in our case, and the computer interface, USB or Ethernet. The wizard ends up with opening the startup dialog with pre-filled options. In our case, it will be a 6-site CPI2-G06 gang device programmer and USB interface. By clicking the Start Device Programmer button, we'll launch the programmer. By default, the GUI opens with the following windows: Buffer Dump, Device and Algorithm Parameters Editor, which serves for preparing the data to be written into the target device, Device Information, and the Program Manager that displays 6 tabs, each one for a single programming site. You can open new windows, resize and move them so the GUI will store a new configuration. Let's observe the main menu toolbar located on the top. The File menu allows to load files to the programmer's buffer dumps and save the data from the buffers to a PC hard drive. The View menu allows to open windows. Besides the default 4 windows, you can open more than one buffer dumps, and the console window to which the programmer permanently streams its activity. The Project menu allows to create, store and manage programming projects. A project is a fundamental concept for the CPI2-Go ISP2 device programmers. Instead of using single steps, such as choosing the device to be programmed, browsing for the file to be written into the device, and setting other properties, it's much more convenient to specify all these options in a single project, store it as one project file, and then open this project file by one mouse click, or by calling it in a command line or as a DLL parameter. You can create and save multiple projects for programming different device types, then you can pick one of the saved projects and launch it from the GUI. The Configure menu opens several configuration dialogs, settings for data in buffers, and blending dynamically changing data with static data loaded to the buffer dumps. Such dynamically changing data is often represented by serial numbers, checksums, and custom signatures. This menu calls the dialog for setting static IP addresses if the programmer is controlled from a local area network via Ethernet interface. The Commands menu enables to launch the self-test and to toggle between the full and simplified user interface. The simplified user interface will be described in a separate video blog. The Scripts menu concentrates the commands managing custom-made scripts for the CPI2-Go ISP2 programmers. The Windows menu controls positions of open windows. The Help menu enables access to the built-in context-sensitive User's Guide. License Management calls the dialog where you can see currently active device library licenses and to activate new licenses. The very bottom option, About, opens the panel that indicates the serial numbers of the programmer main unit and each of the programming modules. The toolbar under the main menu line concentrates icons for frequently used commands. The right part of this toolbar displays grayed-out elementary functions: check, program, verify, read, and erase that are inaccessible right now. The only button command available for the Gang programmer is the auto that launches the auto-programming chain of commands, which is the same for all sites. Let's begin from choosing the target device. For example, our device is Texas Instruments ARM Cortex-M4 microcontroller. Click the Select Device button. In the popped-up dialog, you may either scroll down the device list or use the search mask field to find your device. Listed device part numbers are optionally accomplished with programming interface abbreviations. Some devices can be programmed through different on-chip interfaces. For our TI microcontroller, 3 alternative interfaces are available: GTAG, GTAG chain, and single-wire debug interface. The user should select one implemented in his target board. Let's opt the GTAG interface one and click OK. Then the software will reconfigure the programmer hardware to match the chosen device and programming interface, and will automatically refresh information in all GUI windows and menus. A chosen device part number will appear in the device information window. At the bottom of this window, you may see a link opening the connection diagram for the chosen device. Click the link, and in a while, the connection diagram and cross table will open in your browser. If you connect the programmer through a big 150-pin DIN connector, use the pinout marked as CPI2-Gx connector. In case of using a signal splitter board with 20-pin headers, use the pinout marked as CPI2-P1 connector. Let's now consider how the CPI2-Gx interface enables preparing data to be written into devices. The programmer merges static data and dynamically changing data. Static data consists of the data loaded from the file to buffer dump, mixed with the data set by the device and algorithm parameters editor. Dynamically changing data, unique for each single target device, is usually represented by serial numbers, checksums, signatures, etc. Some devices may have memory belonging to a single layer, but others may have memory belonging to several layers. For example, a chosen TI microcontroller has 2 memory layers, code and EEPROM, and the programmer handles data in these memory layers separately. The GUI enables opening as many buffer dumps as you need. It's convenient for observing different memory ranges of the same memory layer at the same time, or different layers. For example, code and EEPROM here. The buffer dump windows have their own toolbars for frequently used operations with data loaded to the dumps. The data can be loaded from a computer and then modified manually. The Setup button opens the dialog changing the data format. The Block button opens the dialog allowing several operations with data blocks, search options, and others. Later, data from the buffers will physically move from a computer to all memory layers of all target devices at once by a single auto-programming macro command. Normally, contents of memory buffers represent results of the project build made by the application developer. These object files represent static data that should be written into a series of devices. However, sometimes you may need to write in each single device one or a few bytes that represent a unique piece of data, such as a serial number, or a custom signature, or a checksum, or a scanned barcode, or something else. The programmer software is capable of slipping such dynamically changing data into the static data, mostly into the code. Also, the software takes care of an accurate distribution of automatically incrementing serial numbers between the programming modules or sites. Each tab in the serialization checksum log file window opens dialogs that prepares certain types of unique dynamically changing data and specify the destination address in a target device for this parameter. Besides the dedicated parameters such as serial number, checksum, and signature string, the programmer enables operations with custom shadow areas for preparing the data calculated specifically for the case. For example, this can be a unique MAC address of the current device to be programmed, or a unique barcode read out by a barcode reader from the labels taped to the board to be programmed. However, before programming a device, you may tune some parameters without rewriting the entire project. This mechanism, implemented in the Device and Algorithm Parameters Editor window, is convenient for changing such device-specific parameters as fuses, bootloader parameters, registers, programming voltages, clock frequency, and so on. Clicking the parameter opens the setting dialog. The dialog appearance depends on the parameter type. Some of them have only two states and can be toggled, enable, disable. New values for other parameters can be typed in manually. Besides programmable device parameters, you can also make some changes in the device programming algorithm. For example, for the selected device, you can change the clock frequency or VCC voltage. The software will block your attempts to exceed the ranges allowed by the device manufacturer. The window displays modified parameters in red color and issues the See Help prompt over the red strip. It warns that the changes made within the editor window will not be immediately reflected inside of the device memory. If any parameter was modified in this window, an optional command that programs parameters should be added to the auto-programming function list. Only then the parameters will be programmed along with the code and other data. Open the tab Options in the Program Manager window. For the selected TI device, the default batch includes 4 basic commands: erase, blank check, program, and verify, and all of them are applicable to the code layer only. The list does not include any operations with EEPROM, as well as programming the parameters and locking the device against unauthorized reading. To add the commands for writing in these parameters, along with programming the code layer, click the Edit button at the bottom of the Options tab. Add necessary program commands for writing the EEPROM layer and the parameters. The Options tab also includes settings for splitting data from the buffer dump, for writing them into multiple devices, reversing the order of bytes to be programmed, and checking the device ID. The Statistics tab displays the results of programming separated by sites, and enables to limit the number of devices to be programmed in one session. Once again, the Program Manager window has as many side tabs as many programming modules are installed in the Gang programmer. As it was mentioned earlier, all the buttons launching single commands like read and write are inaccessible and grayed out. Clicking the Auto button, the only one accessible in the toolbar, triggers synchronous executing of the same auto-programming batch of commands on all 6 sites. However, there is one trick allowing to execute just a single command on the CPI2-Gx device programmer. For example, you want to read data from previously programmed devices. To do this, remove all other unnecessary commands from the auto-programming list and execute it. For independent control of each site, they all have individual execute buttons. If the programmer is featured with CPI2-Dmux demultiplexer license, then clicking on the arrow button on the top of the Site tab opens the drop-down menu, which allows to configure the order of programming channel activity. Demultiplexer license enables the B channel. If the demultiplexer license is not installed in the programmer, then only the A channel will be active by default, and setting any other combinations will be disabled. Switching the tabs 1 to 6 allows to see the programmer commands and error messages for each site. We've just reviewed basic operations with CPI2-Gx Gang Programmer, accessible from the Graphical User Interface. In practice, the GUI is not the preferable method of control for mass production, but you will have to use it for presetting other methods of control that are more suitable for mass production and for integration of device programmers into automated test equipment. Such methods of control include, but not limited to, the standalone mode, use of the application control interface, SDK, and so on. Use of these control methods are subjects for other video blogs.